Special guest with us today. We get to interview a famous physicist. Sir, will you please tell us your name and tell us about your project?
Oh, thank you for inviting me today. My name is Albert Abraham Michelson. I, with the help of famous chemist Edward W. Morley, helped to compare the speed of light in perpendicular directions. We came up with the idea that with the right material, anyone should be able to measure the motion of the Earth through the luminous ether.
What were you guys trying to do or find?
Well, first with making the project happen, we just placed a beam of light through a beam splitter, and refracted them into two mirrors that also hit a detector. And we were trying to prove that light changed due to different reference frames. We were trying to prove that the ether wind, which was just some sort of motion between the Earth and the ether, would have either pushed or hindered the motion of a light wave.
All right, interesting. Where did the project or experiment occur?
Well, we did this project at the Case Western Reserve University in Cleveland, Ohio. The college lent its laboratory to us, and we used its lab material.
That's great. What other significant events were happening around the world? What was going on at this time?
At this time, not too much. Well, the president at the time was Grover Cleveland, and the physics department also had another scientist who discovered the waves of reception of radio, which was another huge step in understanding light.
Oh, interesting. So who else was involved in this particular project?
Well, I had a partner, as I had previously stated. His name was Edward William Morley. He was also involved in the project. Morley graduated from Cleveland with a chemistry degree. The college also gave his laboratory for the use of the project.
What was your role in this project?
Well, I had already had a stake in it. Because of my fascination with light, I brought my previous research to this project and helped make the contraption in which we did the project. I had conducted a similar project a couple of years ago, and I just used it with lesser equipment, so we upgraded for this one.
Very good, very good. What impact would you say your project has had on the physics community?
Well, this experiment was really key in that it opened the door for alternative explanations for the strange wave-like behavior in light. Ultimately, it helped disprove the case of an ether, which is just a relevance for a frame of light. This meant that no matter what, light would travel at the same speed, and this experiment gave a good case for it.
Great. Last question. What would you say this project has on the effect of the people today, like the modern time?
Well, for the modern time, really is really minimal, but people are using my science and my research today to help maybe get to where we can use time travel. I know it sounds strange, but when it comes to particles traveling faster than light going forward or backward in time, my research today is helping the physics community out in strides.
Wow, that's very impressive, and we appreciate you coming in and talking with us today, Mr. Michelson.
Thank you.
Thank you.